we've got some hard hitters with us today. Just as it looks on my view right here, so that you know, like when they do in the football games, aka soccer games, and they say like in the red pants and the white shirt, we've got Manchester United in the right top corner. That's me, in my view.
I don't think everyone's gonna have the same like layout on their
All right,
screen.
there we go. Wearing the Tecton swag is Mike. And then we've got Willem with the cool stylish headphones and David with half of his face cut off. You might have to adjust your your new, there it is. There, now we got a full shot of him. And in case you all need an introduction on these guys, we've got some heavy hitters. All right. So David is the co-creator of what you probably have heard of, a little tool or platform called Kubeflow. Willem is the co-creator of a little tool or platform that you may have heard of called Feast. And Mike is the co-creator of a tool or platform that you probably have heard of called Tecton. So we're getting all these guys together today to just chat. I want it to be really open, and I already briefed them that you all can feel free to ask questions, and these guys can ask questions of each other. I think it's really nice to have this many smart people in one place at the same time. So I love getting the questions from everyone here. And I love hearing what these guys have to say about answers that come out. Now, the first thing that I'm going to ask, the big question on my mind to start off with some hardballs, is what has been your favorite purchase over the last 10 months during quarantine? And I'll start so you have a minute to think about that one. But I got a little foam maker for milk, and that's by far the best purchase it was $2 at IKEA, and that has been my favorite purchase. So, Mike, I know you got one for me. What do you got?
For me, it's actually obvious. I got a wood pellet barbecue and changed my culinary life. I'm sure a lot of people working from home have been cooking a lot more, and so check that out. I recommend it.
Nice. What about you, David?
I have gotten really into cheese making.
Ooh.
And I like bought all the accoutrements, this like wood old school press for cheeses and so on. So that it's a lot of fun. But probably the most valuable thing is the what do you call it? I sucked it up and bought a tonal, and it's great. It really is.
What?
Like a tonal. It's one of those home workout things for like a Peloton, but like for weights, and
Nice.
it's dynamic and it auto adjusts weights as you're doing it. I know that makes me super whatever bougie, but it's fantastic.
All right, last up,
cool,
Willem.
actually. I'd say two things. One is a mocha pot. So I just have this like ritual of grinding coffee in the morning, making coffee with a mocha pot. And the second is a Blue Yeti microphone.
For all your
because I was just
yes,
struggling
all those
with audio.
shows. Yes, that is useful. Now, I think the next time we do this in person, I'll bring the foam maker. Mike, you can bring your grill. David, you bring the cheese, and Willem, the coffee. And we'll do this in person and have a party out of it.
That's pretty solid. Thanks, by the way, for putting this together. I think this is a really cool idea, and I think it'd be cool to, in a future one, also like have like other, the attendees be able to like ask questions and participate in the audio and stuff like that.
Exactly. Well, if anyone, we used to do it where we would just put everyone on audio. So if anyone wants to do audio questions, you can raise your hand and I'll give you permission.
Oh,
it's
cool.
just that most of the time people got really like shy.
Or forgot to mute.
Yeah. Or people would just like blabber on for a long time, and then it would be like a half an hour later we'd get to ask the next question. So if you have a specific question you want to ask via audio, we will throw you on there. Let's start though, and let's talk about, I think it's probably useful to start with Kubeflow and just get a bit of background on what's going on with Kubeflow and how and for everyone who is, you all probably know this, but the idea here is these two tools that will get you 90% of the way to operational ML. And so I'm thinking that we start just talking about Kubeflow. And for those who aren't so clear on what Kubeflow does, can you give us the brief rundown, David, of just what it does and how it works?
Yeah. So I co-founded Kubeflow while I was still at Google. I had actually just come out of spending about 3 years running the Kubernetes and GKE business while I was at Google, leading or co-leading during that time. And what I saw was a lot of people would set up a Kubernetes cluster and say like, okay, now what do I do with it? And one of the most common things to do with it was machine learning in some capacity, because Kubernetes offers this great declarative platform. It's incredibly scale out and all those kind of things, which machine learning often requires. So we went and looked at a bunch of frameworks out there. There tended to be a lot of very deeply integrated stacks, which is okay, but it means you have to consume everything that designer comes up with. And so what we wanted to do was take a much more cloud native approach to Kubernetes or to ML, and let people really pick and choose components that made sense to them to build out intelligent MLOps pipelines and things like that, but do it in a Kubernetes native way. So we started when we first got started. It was very, very small. There wasn't even pipelines in it. It was just a Jupyter notebook, a TensorFlow CRD, and a serving component, which was TF serving, and I think Selden was there at the same time. Quickly thereafter, people were like, oh, we need a pipeline system to wire all these components together, and we needed an SDK to interface with that pipeline and all that good stuff. So that came very quickly, and since then, we're now on the verge of Kubeflow 1.3. We have 10,000 GitHub stars, a ton of people using it. And it's become this great, deterministic declarative pipeline that you can use to roll out MLOps and things like that in a very important way. Now, one thing that a lot of people ask is like, well, does that mean how are you taking the place of all these other tools? And by and large, we're not. That's the point of Kubeflow. Like, we're not substituting Jupyter. We're not substituting Feast. We're not substituting TensorFlow or PyTorch or Selden or any of these things. What we are is a deployment mechanism for those other tools and a pipeline system to let you wire them together in whatever way it makes sense. And it is also not supposed to be end-to-end. You should absolutely use Spark or Hadoop or whatever you're data processing separately. You should absolutely use a different deployment system for your serving. But within ML, it's a first-class way to roll out these very rich pipelines. And so that's what Kubeflow is.
Can I ask you a question about that motivation, David?
Yeah, absolutely.
I heard you say at the beginning, you were saying like, it is not a big monolithic system. It is basically a way to swap in best of breed or combine different components.
Yeah.
And that is I guess like a lesson that we converged to as we were building the Michelangelo system at Uber. At first, we really built it to be this like big monolithic thing, and then every new use case we took on, it was great for the X use cases we designed it for. It was built to work for them. And then every use case after that, they would have like one thing that would be different. It would be like, but we want to serve these models on the car instead of from the data center, or we want to train some graph neural network thing that can't be trained. We have our own training thing, and so they would want to use like n-1 components of this system and swap in their own component here and there. And so over time, we converged to a model of having. Of just breaking it up into like reusable components.
Absolutely.
That were more like these building blocks that we offered. And, I don't know, like, I guess like my question for you is that was your design of your initial like vision of like, let's build these reusable components and make them easy to assemble together. Was that based on a lesson like the one I just described, or you had that lesson with some previous system, or was there something else that motivated that initial vision?
That's such an interesting question. Look, I'm not smart enough to have more than one playbook, like honest to God. It is, everything you see there is completely stolen from 4 years or whatever. At the time, it was 3 years of building Kubernetes, right? What we saw is people wanted cloud native deployment, right? And they wanted clean isolation between the various steps, exactly like you said, reusable components inside that say, okay, here's my data source, or here's my this. And Kubernetes, still is struggling with that. They have a number of really interesting technologies around that now to describe entire packages, Helm or CNAB or things like that. But yeah, that is exactly it. The idea was, and we're not even close to getting there, even with Kubeflow, right? The idea was services. You pick your services. I want some Feast. I want some Katib. I want some CRD, and I also want that data engineering step that those people over there use. Give them all to me. I'm going to describe how these wire together in a pipeline, and then off we go. We still got ways to go there, and this is going to be one of those things where the problem is that everyone's reinventing everything constantly in ML because it's all new, and no one has kind of come down and said, hey, you know what? You can do whatever you want, but if you use this tool chain in this way, we're going to make you much, much faster. And the thing I always steal from, 2 examples that kind of scarred me for life is Heroku and Ruby on Rails. In my opinion, both of them are the premium experience for what this looks like. Configuration, excuse me, and I'm totally forgetting what their phrase is. It's something over configuration. Convenience over configuration. Convention, thank you. Convention over configuration. Thank you very much. So that is exactly it. I'm trying to establish, not in a capital S standards way, in a lowercase, small as you possibly can get, S standards way. These are the conventions around ML. This is what components should look like. This is what contracts look like. This is what inputs and outputs look like. Pick and choose whatever you want. Wire them together.
I think that was the question I wanted to ask was kind of like, what's the substrate, or what is the non-component aspects that you provide as a platform? Like the reductionist view is, or like the reductionist approach is like, okay, why is Kubeflow different from Kubernetes? Why can't you use Kubernetes? So Kubeflow must be providing some kind of structure or framework there.
Yeah, I think that's a really interesting question. I would love to provide more, right? But the team, the Kubeflow community is still really just trying to get their feet under them, even now, right? Like the investment is not at the Kubernetes level at any major organization, and though many folks are using it, we're not where I would like to be. What I would like the community to do is come up with those standards and say, these are the components that we provide. To be clear, what we provide right now is we provide a number of things in the box that make it very easy to deploy all the components that we feel like are necessary for most ML pipelines, right? CRDs, we deploy Argo for you, and so on. We also give you a great dashboard, and we give you, for better or worse, a nice DSL, so you can write in Python and say, this is my DAG, this is my graph of how I would like this workflow to execute. I can write that all in Python. This depends on that, and this depends on that, and this input's over here. And then we compile that into Argo for your execution. So that's pretty convenient. Is that anywhere close to where I want to be? Of course not. And it's only going to be with people from the community like coming together and saying, oh yeah, we actually should work on this. And I want to call out lots of the folks that are out there, Aricto and Aquasio and Canonical and all these people who are doing work right now upstream to help with simplifying that.
I think there's like a. Sorry, Demetrios.
No worries. You're making my job easy, man.
Oh, okay.
You keep talking.
I mean, I thought it was kind of interesting because like David, some of the abstractions you seek to provide with Kubeflow are they have this value of simplifying some of like the best practice patterns. It's kind of just like a simplification for the data scientist who's or whoever, an ML engineer who is getting started, and they don't want to handle, they may not want to build their own system on they may not want to bring their own component for many of these things. They may want like, I just want the default kind of ML pipeline, and then I have my one custom thing. That's kind of like some of the stuff that we saw building on Michelangelo. And I think as you were saying that, it was reminding me quite a bit of a lot of the value that we seek to provide with the feature store concept, because the feature store, you could see it as like one component that could live within a Kubeflow framework, right? A broader MLOps framework. But what is it doing is it's providing this abstraction to the underlying data infrastructure that there's a whole bunch of different data architecture patterns that can be implemented, like blueprints, so to speak, that can be implemented for, depending on what your use case is. If you're doing like a real-time fraud prediction kind of thing, or you're doing an offline batch thing, or you got to send data for labeling, and so the feature store, we're trying to allow that to use that to simplify some of the decision making that a user would have to do when they're trying to build their MLOps pipeline. And then I see what you guys are doing is kind of like a level above that, which is use the feature store, or whatever you want to use for your data side, and then similar systems for model management and the other components of the MLOps stack. And so it seems like there's like the same kind of patterns being employed to bring the best of breed, but you can swap out components that you want, and you're really like orchestrating kind of like best practice components.
Yeah. No, it's such an interesting point, and let me stress that actually, for those that don't know, the feature store, in my opinion, is probably one of the most overlooked components when it comes to building a production ready pipeline. Like the ability to describe schema, to do your engineering in a well-defined step, to do validation, and to provide first-class interfaces for those later steps to consume data is absolutely critical. It breaks my heart that we didn't have a feature store on day 0 with Kubeflow, because the number one problem in ML is data, right? It's not training, right? Like all the hard part, all the work goes into engineering and understanding and sharing those features and things like that. And Feast obviously is running away with all those components there. And I'll say, like I said, I think I would love to figure out how we kind of standardize as an industry and say, hey, you know what, these are the contracts around a feature store that are so critical, inputs and outputs for a feature store for providing all those steps. And then inside that, we can have active competition, but like every one of them should have, adopt quote unquote that standard. I think that would greatly accelerate a lot of things.
Willem, I see you shaking your head. Yes to that
No,
one.
I was in agreement with that. I think we've had these discussions publicly and internally a lot, moving towards publicly defined contracts, and just nailing those contracts down, whether it's data contracts or API contracts or schemas, is critical. And when you have boundaries of those for all the components in the ecosystem, not just the feature store, then you can actually start swapping things in and out, and you don't have to have a KFDEF deployment for each cloud provider and each environment, right? You can have you don't have to build a component and custom implementation every time. So that's the only scalable approach to kind of a universal platform, like an opinionated machine learning infrastructure that works in multiple contexts.
Well, and David, you've seen it before. You've seen that happen, that standardization happen. So how does it play out? Like, how do we get together and agree on that and say, all right, here's what we need?
It requires kind of a combination of things. And mind you, like, I believe, like I said, in very, very small s standards. Just folks kind of agree that this is a good thing. And if you support it, great, you support it. And if you don't, go knock yourself out with something else. Don't worry about it. We're not going to block you. But like, if you do support this standard, then here's a whole body of tools that instantly know how to read and write from what you describe, right? Think like a pandas data frame, right? That's not a standard. It's just something a lot of people use. And so, but now because it's so common, if you were a data product, literally it would feel like there would be a gap if you didn't go out and do that. I think that's really part of it. But what really happens is this is led by industry leaders like Tecton and Feast and so on. They help say, you know what, we are going to be the bigger citizens here. We think that everyone moving to this will accelerate everyone's business, including ours. And we're going to help develop that standard. And we're going to support that standard on a going forward basis, right? Again, lowercase standard, right? Not something that's submitted to the IETF, just something that we all say like, hey, this is a good thing. And because they have the expertise, they have huge user base, everyone knows who they are and things like that, they can lead that. So it's really kind of a combination of things. I do want to say though, like it only works if there are commercial opportunities. I'll be honest with you, right? Like I just don't, even around things like HTTP and TCP and other things like that are like the internet standards of choice, right? Those only really started to take off, this is before my time, but they only started to take off when major companies started coming along saying, oh, you know what, we can make money off of selling networking gear or servers or whatever. And then those standards became a mechanism to going and doing that. And I think that's where the phase we're at right now. How is this going to provide value to users? Because it makes it very easy to swap things in and out. Who are the major players in this? Who can help contribute to these standards? Obviously, you're talking to two of them right now, who I think are great. And like I said, what does this standard look like? Is it dynamic? Is it contributed to a foundation, or not even a foundation? Does it just have open governance? It doesn't have to be in a foundation. In fact, foundation, there's kind of like foundation washing nowadays, where like a single company who basically controls the entire base, and it only works with their stuff, contributes it to a foundation, but it doesn't really, there's nothing special about it. It's just, it's foundation washed. So you got to be really sensitive to that. Look at the code base, look at how many platforms they support. If you're only looking at something and it only supports a single stack, that's a huge code smell, or business model smell, or whatever it might be. So certainly something to watch out for. But like I said, this is, I think if there was anything, particularly in the data space, that's holding people back, it's that they don't realize how big a miss this is, not having a feature store in place, and not having standards in place. It's really one of those things where a data scientist, a phenomenal data scientist, a phenomenal data engineer is going to their laptop and hacking together some Python and like doing some data engineering and changing, zip code from GPS coordinates to, numbers or categories. And then they it works, and then they quit and go to another job, and the next person has to completely re-engineer everything because they've forgot how they did it.
Nice.
David, I liked your point about small s standards, large s standards, and it seems to me like you're implying that hey, the value of standards can be, a lot of the benefits of a standard can be gotten from small s standards without a lot of the costs and basically the bullshit that comes along with large s standards. Is that your point there? And also, what kind of mistakes have you seen people go through as they're trying to establish kind of their small s standards?
Yeah, I think it's really interesting that there are a couple of thoughts there. That is exactly the point I'm making. Don't, like I said, just submitting to a foundation, really not that big a benefit, right? Like I would look much more closely at non-corporate contributors to a thing, or non-single company contributors to a thing. And also on top of that, I would also look at how open the governance is, which by the way, Kubeflow is failing at right now, and we're working on that. But those are two really critical things that can be achieved. As far as the standards are concerned, there's really two big things, right? Maybe three. The first is just publishing a standard is to some degree meaningless, right? I can write a standard for anything, but unless there's code and human beings and work behind it to support it and use it and share it, it's not a standard, right?
Yeah, this is kind of what I'm asking about. It's not like authoring a standard that is the hard part.
Exactly. You got to have energy. You have to have motivation for continuing to support it and those kind of things. Number two, I think, like, what is your N? If it's just N, that's not a standard. That's just like an API interface for a single company. If it's N+1, maybe. If it's N+2, now you're starting to get some questions. And N+2 people making money off this standard, like, that is a good thing, making money. Very, very important, and helps align forces. And there's a lot of concern out there about, like, oh, does this slow innovation and things like that? Not if you do it right. If you do it right, it, like, accelerates everyone's innovation, because it allows you to commoditize a set of things that wasn't that interesting in the first place, right? It, like, the fact that I use an UUID instead of an int for my ID, who fucking cares? Just do it, right? Like, that's okay. Standardize on something and go. Yes, you're going to bike shed until the cows come home about that, but just make a decision. And that is so much better than having no decision and everyone having to, write their own manual parsers and figure it out on their own. That's my thinking.
So I love where this is going, and I think it's really interesting to look at Kubeflow in this way, and having these basically Lego blocks that you can interchange. And last week I was leading a debate, and one of the questions for the debate that I was going to ask people was, is it going to be one tool to rule them all in the whole entire pipeline, or is it going to be this best in breed? And I ultimately got rid of that question because nobody wanted to argue for one tool to rule them all. So I think we know the answer to that already, but I'd love to hear why you guys feel like, is it just too big of a problem right now? And since there's no standardizations, one tool to rule them all won't be the trick. But the whole idea that we're talking about today is these two tools, right? Like a feature store combined with Kubeflow is going to get you almost all the way there. And so the first question would be like that one tool to rule them all. And people in the chat, feel free to throw up if you feel any differently about this one tool to rule them all. And then the second question is like, okay, well then, do you feel that a feature store plus Kubeflow will get you 90% of the way there? And I'll let you take a swing at this first, Mike.
Yeah, I'm definitely in there's not one tool to rule them all kind of thing. We built, one tool, as I mentioned earlier, like at Uber, we built the one platform to do everything. And that worked really great for a subset of use cases, but it wasn't the best solution for every use case. And I think that everybody, that's here will agree that the MLOps space is still evolving and quite quickly. And my opinion is that we're not going to, the space is not going to evolve to the point where there's just one tool that like dominates that is just like the MLOps tool, but the boundaries of like what makes sense for different types of tools to exist, it will be partitioned into many different groups. And so, I think what we should all be optimizing for right now and thinking about is like, how do we allow for these different tools to work together really well? We may, like, for example, we're building a feature store, but like a feature store is useless if it can't, if other systems can't use it to train their models, use it to serve their models. And so this notion, that's why I was kind of like digging into the standards thing, because the kind of standards help define the interfaces which allow for this compatibility between tools. And so, there's like a lot of people building monitoring tools right now, and we want to be able to integrate with them and have them plug into our feature store. And why would we go out and try to build every single part of the ML stack? That's not like a winning long-term strategy. And so the concept of like being like really optimizing for compatibility with the rest of the stack is quite important. And I think that's really like where our focus should be. Like, how do we evolve this space in a way that like maximizes that compatibility? Because just like that int and like the kind of like different thing about the standards example, the standards are there to like reduce friction. So you just agree on a standard. Doesn't matter if it's the best standard, but it'll help you reduce friction. And so then if you're not, an MLOps expert and you're just trying to get started, you don't get stuck in this like months of like, oh, I tried this one tool, but then like I spent 3 weeks trying to connect it to this thing and it didn't work. And so then I threw it away. But like, then I tried using tool A with this other alternative and was using tool B and getting just stuck in this stuff. That's the kind of friction that I think we need to remove if we want this space to move forward. And that's going to involve, defining these standards, but also like that requires pretty hard partitioning. Like the standards involve like partitioning of responsibilities of all of the work that needs to be done in this space to these different components. And, we'll see like best of breed in each of these different groups. So I don't think maybe that's not surprising, but I don't think there is like a opportunity for there to be one tool to rule them all.
Yeah.
Maybe I should just take a stab at like, what is the case for the one tool if nobody's willing to do that? But it seems like in my mind that, the large cloud providers is the closest thing to the one tool, right? So in which case would a team want to adopt that? It's often the case that, it's convenience or, they just don't have the bandwidth or, the engineers or the team is not large enough to kind of deploy internal tooling or run their own, Kubeflow or, Feast or Tecton. So I'd say that's the only use case or the only primary driver. And I think the ask is from the open source side and from like the kind of like the Tectons of the world is how can we make it super, super easy for teams to adopt? How can we make it like a low overhead for teams to deploy their own open source tooling so that, if you use tools like Feast, that it's easy to integrate. It's a reversible decision if you decide that you don't need the tool, and that these kind of contracts and best practices are kind of built in. And then you get the best of both worlds, right? Low overhead as well as flexibility in your architecture. You don't have to, like, if you end up adopting like an Amazon tool, maybe it doesn't address your use case fully, and that last 10%, you'll need to go to like an engineering team and say, okay, you have to compromise on, let's say, latency or some aspect that you found important because the cloud provider won't bend in the way that like a open source tool will or a Tecton will accommodate different use cases because of its smaller footprint.
Yeah, I couldn't agree more with everyone. I'll say that I think that I'll take the slightly controversial position of saying like I think there is one tool to rule them all, but that's not an ML tool. I think it's Kubernetes, in my opinion. Right now, obviously, I bet on Kubeflow for that, but like that's not the point that I'm trying to make here. I am saying that what we need in ML is a way for a number of independent parties to work together, to each of which to isolate and componentize their particular component and deploy those components together, and then have a standard way for them to interface, discover each other, and move on and find out how everything is going. To me, that's Kubernetes with external APIs and things like that. I will echo Mike and Willem's point. Like it can be very, very alluring to like go and suck down an entire stack. But the moment you like take 1 inch of deviation from a single stack, you basically have to rewrite the entire thing from scratch. And it is so painful. So, again, huge smell. If you're getting everything from a single provider, I don't care if it's a cloud provider, I don't care if it's an on-prem solution, whatever, the likelihood that some or all of the people actually doing the work here are going to be unhappy at some point soon is pretty large. And it's just something to be aware of. Again, that can be a bet you make. You don't want to like over optimize at the beginning and so on. But the number of times like I put up that slide, that tweet from years ago that's still true today. Took 3 weeks to get the model to converge, took 11 months, and the thing's still not in production. And the reason is because I can tell you exactly what happened. A very, very smart data scientist sat down at her machine, typed Jupyter notebook, hacked away at it, got area under the curve to look great, and said, okay, call it a day, right? The difference between that Jupyter notebook converging on her local laptop and that thing being packaged, security checked, rolled out in production, monitored, studied, using live data, blah, 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 is the Grand Canyon. And the closer you can get to having your people develop using production-ready tools like Tecton and Feast and so on for sucking in data, for doing it in a well-structured way, even using Kubeflow to think about pipelines, doing that in a production-ready way instead of a single Python file, the sooner you're going to be able to roll out those things to production.
So
sorry,
go ahead. Go ahead, Mike.
Yeah, I think I was just thinking about why does this question always come up though? Like who is saying there's one tool to rule them all, right? And I think part of the challenge is there's people in industry who are like, oh, we are the ML end to end, we do everything, right? And I don't think that there is I don't think that that's necessarily targeting the same group of users as a lot of the the folks that are building components for Kubeflow, for example.
Yeah.
I think there's a different layer of jobs to be done for the different users that they're targeting. If you're a data IQ or something, something that's promising an end-to-end ML experience, you may be targeting someone who is not trying to innovate they're just trying to build a simple model and get it done with and move on, compared to someone who's trying to I want to build some unique behavior into my product and use machine learning. And so there's kind of this am I trying to build machine learning or use machine learning? And there's that kind of distinction which can help classify does this person, might they need just an off-the-shelf end-to-end ML as a service application kind of thing, or do they need to dive in and build some stuff with machine learning? And then I think that same kind of decisioning happens at when they're starting to adopt Kubeflow, right, or something like that, and they're looking at these various components. And the great thing about I guess a system like Kubeflow is okay, my goal is not to innovate at the model serving layer. I'm just trying to make a better model so I can dig in and build on the modeling layer. But then I have all the other stuff that just kind of batteries included works out of the box, basically. And I think that's kind of the distinction. And because the messaging is so confused, there's so much overlap between the people who are we do everything, AutoML, end to end, everything, don't worry about any of the details, and the platform types of tools. That's really confusing to people who are new to the space.
Yeah.
What should I actually use? I don't know. I'm going to go get a demo from Data Robot, and it's totally different.
The crazy part about it is so you're so correct. And I do want to bring it back to Tecton and Feast and things like that, because I can't stress enough, one of the things that is the least production ready here tends to be this feature engineering step. I can promise you, if I went out to GitHub and did a search for code out there that literally converted whatever floats to ints for use in ML pipelines because they were using the wrong precision or something like that, I bet I would come back with 20 million results. Everyone has done it themselves, and they all have special cases and things like that, and probably 20 million within a single company. Everyone's like, oh, who cares? I'm just going to do this. I'm just going to convert it myself. I'm going to round. I'm going to drop precision, whatever it is. Guess what? You're all doing it wrong. You're doing it differently. You're non-standard. And so that means model over here is not going to work in model over there. That's why it's so critical that we push great tooling, right? What you don't want to have this happen is you don't want to introduce a layer and then make people slower. You want to have great tooling out there, like feature stores that let you centralize some of this stuff. And yes, okay, I have to now learn something slightly new, but it will make me so much faster because it means I don't have to do these things. And that's absolutely critical.
Yeah, and I think actually that kind of gives me an idea of a better way to describe some of kind of what a feature store does, because we were just talking about am I building ML or am I using ML? And I think the idea of the feature store is to kind of decouple parts of the feature engineering experience to allow you to build your features, but use like productionized pipelines and stuff like that. So you don't have to innovate on the whole, okay, now how do I like load all this stuff into, all the things that a feature store does and monitor my features and log these features and turn them into training data, all that stuff. You just want to, you just know the logic that you want to have going into your feature, something you developed in a notebook. And so I think like a lot of the tooling in the MLOps space comes from like separating layers into like the building and using more nicely that better aligns with like what the user is trying to do.
I see Willem is nodding his head again in agreement.
I think there's that's good points, and I think that's you can zoom out from there as well and just look at like ML data and the unique requirements that we have. I mean, we've spoken about this before. So the feature store is positioned kind of strategically between the production and kind of offline world, where you're for one group authoring data, authoring features, and that's a whole problem domain in its own, right? And this doesn't actually, it's not limited to even machine learning, right? This kind of duplication of transformations, extends to BI, I guess, and you can, search GitHub and you find 1 million implementations for how to do a geohash and all these kinds of things, right? So that's one area that we're heavily focused on, and the others are kind of like the environments are kind of distinct. Feature stores are operational systems that are focused on machine learning. So we're trying to address the kind of transformation problem, Tecton especially, and also, if you've got, production data and a production environment that's built in a way that is, by design different from the offline environment, where, you've got, might not be logging the same data, the same systems are not running, the same teams are not running. It's not a surprise that, people are failing to move from one environment to the next. And it's such a big problem, and people, these are different groups of people, these are different teams, don't understand the complexity involved between shipping code, that is dependent on data into a different environment that has a view of, other data and other completely in a different operational context, and then have that run and then have that drive your business decision making. It's wild that people are hacking tools together. Each company's doing this on their own and expecting it to work. So that's kind of the infrastructure that we want to provide. I mean, we can talk about that kind of whole space. It's non-trivial, and we've spent a couple of years in the space already, and there's like it's a deep well of problems to be solved there.
Yeah, I think actually like that really that came up in a big way in a recent customer conversation where it was just a plain as day problem where they have a production environment. The data is totally different in production, and this is a big bank, very different than what's in their staging environment and their dev environment. And they have people who are operating in their development environment trying to build these models, but they don't even have access to the production data, and they are trying to figure out like how do we build something in production, or how do we build something in the development environment and test it in a way that we're confident that we can roll it out to production, and how do we wire up all the data pipelines to allow for the proper stages of validation as we go into staging and into production. These are just really complicated things, and it's just one, and like, why is ML data different? This is just one of the major factors, because your applications, the code that you're deploying, its relationship to the data environment is unique now. It's like way more coupled than if you were just like deploying like kind of like a state, even in just like a model, like a stateless model, right? Here you have like a completely different data environment that you have to interact with. And so people face these problems of like, I have this data that's available in production. I need to have it available in my analytic or development environment for me to build with. But similarly, there's these other things that bring this data into my analytic environment. I built something cool with it. I built a model on all this data that's in my warehouse, for example. But I want to deploy that model. That data is not available in the production environment. So then I get blocked. And so it's kind of like a bi-directional thing that people continually run into. And so building the abstractions to automate some of the pipelines to kind of bridge these environments is one of the key values that we think feature stores provide. And so we continually run into that all the time.
Such
I
good
couldn't agree more.
points. Yeah, these are awesome points. And I want to ask one final question because we're kind of getting down to the end of our hour. Just so that we make sure, do any of you have a hard stop right now? Just in case we go over?
Not
All of you
hard,
do.
but I can't go on forever.
I could sit here and listen to you guys talk forever, just to let you know. So I want to know, this was a question I sourced from some people in the community, and they were asking about what are some horror stories that you've had? Like, give us some war stories of doing things wrong and what you've learned from them. And specifically, like, when your product has failed, or your platform, whatever it is that you're creating, has failed, like, what did you learn from that? And I'm gonna just pick out maybe Willem to go first, because I know you got some great ones with Feast. And
well, I mean, there's loads.
there.
It's not just Feast. I mean, whenever you're kind of engineering software, you've got 1,000 ways to do things wrong that you've learned, and maybe one or two that actually worked. But I think with Feast, one of the big lessons we learned was that, as engineers, we started on the kind of production environment, and we tried to address our own problems first, and then we worked backwards towards kind of like the data science. There's kind of there's consumption and there's the production side of a feature store. They're creating features and they're using the features, right? So we started on the usage and the operational side and moved backwards. And if you start there, you're kind of like comfortable with Kubernetes, you're comfortable building services and deploying with Helm and Terraform, and it's platform building, right? But when you get all the way back to the data science lifecycle and the way that they interact with systems, things they're comfortable with, the familiar workflows, they want to use libraries, they want to use frameworks, and it's much harder to take a system like Feast and package it up in a notebook and tell a data scientist this is how you can use it locally. And so I think the lesson that I learned there was that you should question whether you should be building from the bottom up, understand your complete user base from as early as possible. Because going from top down and breaking a system down and making it more modular or lighter weight is way, way harder, because it's kind of like a Kool-Aid that you drink with Kubernetes that you can just deploy 10 services and databases and all these YAMLs and go crazy, and it's easy. But if you want to package that up into a notebook, it's almost impossible. But the reverse is totally doable. So I think that's one of the things we're kind of like thinking about. But we're kind of happy with our current architecture.
All right, who's up next? I'm going to let David take a swing at it.
I think I actually asked this question on Twitter, actually, about, I want to say about 2 years ago. And I created a public gist around it. I got to go find it.
Wait, about your failures or everyone else's?
No, about like general
what are my
failures.
Worst failures?
Yeah, what are general failures, like classes of failures. And I literally had 3 columns of 10-point font of categories of failures. There are so many. I would say the number one failure you see all the time is I kind of referenced it earlier, the very capable developer who develops on her laptop, outside of code, outside of any production system, maybe even gets it running in production, right? And then she leaves the company, and that's it. No one knows how that was built. No one knows what the history was. There's just this random binary running in production. It's embedded as a library or thrown in like a Flask container. Nobody knows what the hell to do with it. And yet it's some critical component. And I mean, it just happens all the time. And it's not really her fault. It's us. It's the data community's fault, who doesn't give her great tools, who doesn't integrate her into the software development lifecycle. These are software developers. They are not special cases. They are software developers. They create code that converts things into binaries that eventually become used. And we need to pull them in through great tooling and integration and things like that.
That's a great point. That's such a good point on that. All right, Mike, take us.
Okay, the thing that immediately came to mind for me is just a variety of examples through, my, I guess, history, my experience of times when the simplest option was not tried first. and people overcomplicated things. And I remember just one example distinctly. We were building the ETA models at Uber, and there certainly was a lot of thinking about like, hey, well, you know, the world changes regularly. We need to have our models retrain automatically, you know, regularly. And there was this team spent a whole bunch of effort trying to figure out how to do automated retraining and online learning and stuff like that. And the whole time I remember thinking like, you know, there's a progression, and we're at like stage 0 in complexity, and we're jumping to like stage 5. You know, let's go to 1 and then 2 and then 3. And so, you know, what ended up happening is like they did this huge experiment in this very long, like operations heavy thing about online learning and stuff like that. And 99% of that gain could have just come from, at the end of the day, we figured out could have just come from having more real-time signals feed into that model. And you don't need to update your model all the time. You just need to have a simpler way for it to have access to the current state of the world, which is, you know, a real-time feature. And so the, you know, that's a particular example, but the broader theme was just about like, be very careful about the operational overhead of stuff you're taking on, and try to figure out like the simplest possible way to solve this problem, and most likely try that first. And I think starting simple is something that's really easy for people to forget about.
That's some wisdom right there. It's start simple and then get complicated, but don't jump to it. And I know that this is
stay simple. That could just be good enough for you.
Absolutely.
Stay simple.
Stay simple if you can. And I know that's a common complaint, or just like, I guess it's very much innate in engineers' minds to want to do the difficult thing, right? And like try and jump to, oh, well, we could fix it like this and like that. And then it just becomes this bloated, complicated solution when it could have just been something much easier than that. And you wouldn't have had to spend so much time and energy and resources on.
And I think this is not like a unique thing to machine learning. You know, this is in every domain of engineering. But I think it comes up a little bit more in machine learning, just because the machine learning is a little bit newer, so people don't have like a really fine-tuned intuition about the potential complexities of different decisions and like operational overhead of different paths they might go down. And so that's where probably like some teams you know, run into some trouble, because they're you know, people doing it for the first time a lot. And so that's where you particularly want to start simple.
Yep.
Yeah, you bring up such an excellent point. If you kind of scratch your head and say like, boy, shouldn't someone have invented this already, or shouldn't someone use this? That's a really important thing. Like, most likely someone has. Please try your best not to invent it. That said, we're in an incredibly fast-moving space, so there's every possibility no one has. But even stuff like, I'm a big fan of, for example, cookie cutter data science, right? It's a repo out there. It's trivial to set up your own well-structured repo, and it's a great starting point, right? Just start there instead of like coming up with your own repo structure. You use a feature store. Please, dear God, use a feature store. Like, I cannot stress enough the number of people doing manual, totally non-repeatable data transformations, right? Like, if you use sed or awk or grep or anything in your feature transformation, if you're exporting to a CSV, man, I do not envy your SREs. Please use tools to make this more reliable. And like I was saying in chat, use a declarative pipeline at the end of the day. Sure, I'm a fan of Kubeflow. I don't care what. Use Jenkins. Use GitHub Actions. Use anything that automates the process of going through everything. Because if you're doing things manually, those are human beings who are going to forget, going to change their mind, going to leave the company, going to whatever. Code never leaves, and it's there forever, and that's incredibly important.
So you also said in the chat just now, which I'm going to quote you on, is MLOps is a lifestyle.
It is.
So MLOps is a lifestyle. You're going to be your quote slide. I know I'm just seeing now that we got people raising their hands and asking questions in the chat. I'm sorry I did not get to you. This has been the easiest meetup that I've ever done. I think next time I can just go and grab some coffee or tea and popcorn and let you guys do it yourselves. Thank you so much for coming on here and talking to us. We got a little off track, I'm going to be honest. We were supposed to talk about the 2 tools that get you 90% there. I guess we kind of talked about that, but what else we talked about was absolutely amazing. I knew it was going to be a great conversation with the 3 of you, and I cannot thank you enough for joining me and giving us all this, just enlightening the rest of us to the way that you're seeing the MLOps ecosystem right now and how things play out.
Cool. Thanks again, and thanks for the putting this together. And we'll be on MLOps community, so excited to learn more from everybody there.
And thank you so much. I want to reiterate that. Thank you for pulling this together, and thank you so much for really getting a wonderful community going. I can't stress enough the number of people I see in there, real luminaries, and everyone who have questions and comments and feedback has been terrific.
Yeah, it's what Todd Underwood said the other day when I was talking to him, is that people that are doing this right now are the ones who are either going to A, write the books on this, or B, be the first readers of the books on this. And that's really what it feels like right now in the community. So again, shameless plug, if you are not in our community, I'm going to throw the link to the chat or the Slack right now in the chat, and we will see everybody in there. Willem, Mike, and David are all in there, so feel free to reach out. I think they are easily accessible, and thanks again.
Cool,
we
thank
will
you.
see you all later.
Thanks, Steve. Bye.
Thanks.